Well, good evening and welcome to Space Oddities. How are you all on this Tuesday evening? Hope you're well. Thank you so much for joining us, as always. Joined by the usual suspects this evening is we've got Michael. Hi, Mike.
Hi there.
Roger.
Good evening.
Daz, who seems to be distracted at the moment.
G'day, g'day, g'day. How are
G'day,
you all?
g'day, Daz.
Put a
We hope
shrimp
to
on
have
the
Lou
barbie.
joining us later. He had a doctor's appointment that he hopes to get back from in time, so we'll see. Tonight, we're going to be taking a look at the British space program, particularly the Saxavord Spaceport in Shetland, and the whole business of when we're going to get launches from there. As you may know, a German company called Rocket Factory is going to launch their first rocket from there. When's it due, Michael? Sometime in the late summer?
Sometime, probably the last quarter. I
Oh,
think.
sometime last quarter.
Yeah.
Anyway, Michael will be telling us all about that. This launch by Rocket Factory Augsburg, German company. First launch from the new British spaceport, as I said, at Saxavord on
Yeah.
Shetland. And hopefully the first successful launch from a British spaceport after the Virgin launch didn't go to plan and failed out of Spaceport Cornwall. So I'm going to tell you about that, and we got the usual features, we got the news, and of course Daz is going to tell us what's going on the Sun a little later this evening. So thank you all for being here. Obviously, we'd like to thank you all for buying us coffees and making donations. That's very, very kind of you. If you do want to support Space Oddities, the easiest way, or one of the ways, is to buy us a coffee. You can scan the link here, or scan the code here, to go to the Buy Me a Coffee page where you can buy us a coffee if you would like to, and obviously it's much appreciated. Also, of course, you can buy a super chat. You'll see the icon in the chat there. And we've got a few ways you can support us. And as always, all of the money goes to keeping the channel running. So thank you very much for that. Just a quick plug again for our wonderful Space Oddities merchandise. And you can go to the Space Oddities shop by scanning this code. It should have just popped up in the chat as well, where you can buy t-shirts and hoodies of our old 2023 design and the new summer collection Space Oddities merchandise for this year. And t-shirts are £20, including UK postage and packing. And hoodies start at £40, including UK postage and packing. And all the details you'll find if you scan the code there or click the link in the chat. So there we are. Be the first on your block to wear wonderful Space Oddities merchandise and spread the word, which is what I'm sure we all would like. So let's see who we've got in this evening. Joining us this evening, I can see Derek's in, and we've got Ian. Hi, Ian. And we've got Alan. Hi, Alan. And Lee and Kev and Sandra. Glad you got your posters. Nice to see you here. And who else we got? And Jerry. Hi, Jerry. Nice to see you. Hope you're all well and enjoying your week so far. So, without more ado,
I don't think Derek signed off from last week. That's why he was first in.
Right. So, without more ado, we will go over to our usual feature with Roger looking at the night sky. We haven't actually had any entries for our gallery this week to show you, but that's a bit of a shame. So do please keep your images coming into us for the gallery. You can mail them to spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. Send them one image per email, please, and somewhere in the title of your email, if you could include the word gallery, that will mean they're automatically pulled out for Roger's perusal. So there we are. So Roger, what's on in the night sky this week?
Oh, nothing too exciting, unfortunately. It's getting to the point where there's no astronomical darkness and there's not much happening planetary-wise in the night sky, but we shall see as the presentation progresses. So, we've got a waning moon at the moment. Here's one I took a couple of mornings ago. I mean, up in the wee hours of the morning getting these images, and they're
beautiful.
worth doing. Solar activity is not doing too badly. As you can see, the old 3664 is still on show, although it isn't as anywhere near its capacity of sunspots, but it's still producing a bit of energy. More about that later. And here we go. We've got the new moon on Thursday. So if there is any chance of any clear skies, this week is a reasonable chance to get anything, hopefully, if you want to try and get anything while there's no proper darkness. But take it while you can. Here we are through the night sky. This is at midnight. The reason I've done this is because we got the Milky Way core coming up through. And that should be of some interest to maybe some landscape astrophotographers to get a nice vantage of the looping Milky Way in the background.
Indeed.
And,
Looping,
we've got
looping. I like that.
Leo and Virgo with all those galaxies now diminishing over to the western horizon. And we've now got the summer triangle now starting to take its pride of place in the southern and almost zenith parts of the night sky, which is nice to see. Unfortunately, we still have no planets at the moment, but you'll see where they are after this week's presentation of the night sky. Here we are. This isn't a true representation because it's not taken into account the glare of the early morning sky, but it gives you an idea of where the planets are. We've got Saturn, Venus, Mars, Jupiter, Mercury, and Venus, which is just going over to the other side, so it will become an evening object as the weeks progressed. Obviously, with this magnificent, another sort of once-in-a-lifetime alignment of the planets, which you could see very plainly to some accounts through careful observation of the planets in the morning sky. But if you did get a clear sky, you would probably just about get Saturn, maybe Mars, and Jupiter. The others you would have to sort of say that they were there, but with the brightness of the dawn sky, it's just not really possible. So overexcited media people getting to wind people up, and people wondering why on Earth you only saw two of the planets, maybe. But as the week progresses, you can start to see that Venus is now appearing after sunset. But obviously, the rest of the planets will take their turns to do the same, but that won't be until the autumn and winter. Comet Obers is still available, although it is still in the glare of the sunset, and it will be quite low down before it does get any chance of darkness that there can be for this time of the year. But there is still an opportunity to see it if you've got a very good low horizon. It is becoming more naked eye visibility, but obviously you will have to use binoculars to try and find it because of the brightness of the sun still lightening up the sky. So Comet Sushenson Atlas is still exiting Virgo. That's obviously still not as bright as the other comet, but it is developing more of a tail and will become much more of an interesting object towards the latter part of September and October. The latest forecast is it to be about a magnitude 0.2.
Wow.
Allegedly. But
right.
They have been known to get it wrong, haven't they? So it's still about magnitude 9.4 at the moment, gradually brightening up. It is taking a long time to brighten up, but it's still got a little bit of a distance to travel towards the sun to get the brighter magnitudes, but the opportunity is there. Due to the fact that we have no other entries, I'm afraid it's just the one-man show. So here we go with some of the images that I've put in. They are all solar images of the last couple of days, so please bear with me.
Oh, that's nice.
It gives you an idea of some of the activity around the perimeter there as well. So it's still showing nicely, and we've got 3697, which was the 03664, which is coming up to the centre part, but I haven't managed to obtain any images in the last 2 days. So it's just on the other side of the side there. So it's heading towards the western part.
Yeah, so it's moved just past the
Just
middle
past
now.
the other half of the disc.
Yeah.
So okay, here's some activities that of the flares there. So it's quite interesting. I've been trying to get some time lapses, but I failed miserably. I'm afraid I've not been too lucky with the time lapses of late, but I'll keep persevering with it. And here's some of the activity of some of the sunspots. There is a lot of solar granulation on here, but it does show you quite clearly the magnetic interactions of the sunspots there.
Yeah.
Just like the iron filings that you used to get on the magnets going from north to south. And there are quite a few bridges over the sunspots there on the groups on the right-hand side. Yeah. So those sunspots are all sort of interacting and producing quite a lot of activity. And there has been, I have seen on some of the time lapses, some flaring going on over there. So we shall see how those suspected activities will react with our atmosphere as well.
Was this the old AR 3663?
I think so, yes.
And the one following it, I think, is it's been numbered in the new number, because I think the one on the right is the old, which gave us quite a bit of action last time it come round. This is about the 4th time it's been around, but it's been very subdued this time. We've had virtually hardly anything from it. But this one behind it, this is the two groups, because they're two separate groups. This actually, the one behind it actually fired off a big coronal mass ejection today. But because they're so close to the limb, it'll be pushing out towards the west and north of us. So we might get a tag on it, but we'll talk about that a little bit later.
Okay. Right. That concludes the presentation from myself.
Okay. Thank you ever so much. That's fantastic. Right, well, what we'll do now, we'll move straight on to the news. Just give me a second to sort myself out here. So this is the news for this week. A few they're all very interesting things, I think. But first of all, the James Webb Space Telescope has discovered the oldest known galaxy so far. In fact, it's discovered 2 of about the same age. One of them is known as Jade's GSZ 14-0, but of course you knew that. And it's in the inset picture here. It is approximately 290 million years, or we're seeing it as it was just 290 million years after the Big Bang. So this is an extremely young galaxy, the youngest yet discovered by the James Webb Telescope. Now, the thing about this is that it's a very well-developed galaxy that appears to be creating a lot of stars. So how did it get this mature this early in the universe's existence? Now, I know for us 290 million years is a bit of a long time, but astronomically speaking, in terms of galaxies, it's not, of course, and compared to the age of the universe, it's nothing. So here we have again a young galaxy forming stars, quite mature in its formation, very, very early after the Big Bang. So the question is, again, what is it that we're not understanding about galactic evolution that it can happen so fast in the blink of an eye compared to the age of the universe? And if you look at this a bit closer, here's the other one, Jade's GSZ 14-1. And this is not so well formed, not so well defined, but it is about the same age, about 290 million years after the Big Bang. And here's 14-0. The light on the left is from a galaxy that lies between us and Z14-0. But the amazing thing about this galaxy is its size, because it measures approximately 1,600 light years across, which is, for its age, a big galaxy. So there's obviously something we're not understanding, or we've missed something about how galaxies can develop so quickly in the early universe. So obviously more is needed on that. Here's the spectrum for that galaxy. The light peaks around the 2 micron mark. It's very bright, and it's it's an amazingly active galaxy for one so young. Now, next thing, many congratulations to China for landing Chang'e 6 on the moon, taking a sample and lifting off again. So here is the landing video from Chang'e 6 as it approached the lunar surface on the far side of the moon. And the probe made, by all accounts, a perfect touchdown. And there you are, it's down. And also, here's a video of the actual sample of the lunar regolith being taken by the rover. And it's really good to see this happening in action. Now, of course, it's thought that the rocks on the far side of the moon are quite different to the rocks on the near side of the moon. We don't know exactly why and what it signifies. And here's the sample being an animation of how the sample was hoisted back aboard the rover. But now you'll get to see the actual thing. So this is a camera mounted on the lander. And here's the sample being hoisted back on board and poured, if that's the right word, into a receptacle, which forms part of the launch vehicle. And there we are, it's being poured into there. And that sample, as part of the launch vehicle, blasted off from the moon's surface yesterday and is now on its way back to Earth. It will arrive back to Earth on June the 28th and parachute down to a remote part of Mongolia, where it will be recovered. The Chinese are obviously got first dibs on analyzing that important sample from the far side of the moon. Scientists worldwide are really excited about this because we don't know much, or if anything, about the geology of the far side of the moon in detail. But the Chinese have said that once they've analyzed it, they will give bits of the sample to scientists worldwide. They collected about 2 kilograms in all. So there's plenty of material to go round to the world's scientists to look at it and try and work out the exact geology of the far side of the moon. So what an exciting mission this has been. There was no live coverage of the landing from the Chinese, unfortunately, that we could bring you. But the mission seems to have gone exceptionally well so far, and we just have to hope that the sample is returned to the Earth safely. That wasn't the only thing going on with the lander. It released a small rover onto the surface to do further analysis of the surface. And here's a lovely image taken from that rover of the lander sitting on the surface. Don't forget, we're looking at a lander sitting on the far side of the moon. And this is all incredible. And the lovely thing about here is they stuck out a robot arm and deployed a Chinese flag, which the little rover photographed just as they've finished deploying the Chinese flag. So the Chinese have staked their claim, and this is science. Politics shouldn't come into this at all. This is all fantastic science, and this is an amazing photo from the far side of the moon. So congratulations to everybody involved in China with the Chang'e 6 mission. They've already got plans for Chang'e 7 to land on the moon. China is actually doing a lot in space, and they've got big plans for the solar system. One week we'll bring you an in-depth look at China's space ambitions and exactly what they're doing, because at the moment they're really putting a lot of money into the exploration of space, and obviously we hope that continues. Now,
Andy, sorry, just before we move on, That last picture that were taken by the little rover, is
Just
that
one
right?
sec.
Is that the scrape where they've actually taken out the soil just there? Because it looks as though it's freshly. You reckon that's where they scraped out the soil?
No, I don't believe it is. I think it's
Mm,
too big.
yeah,
Yeah,
so I was just wondering because it just
yeah,
looks
yeah,
as though it's freshly disturbed and all that. Because you can see the little tire tracks.
yeah. That's right. No, I don't think it is.
Mm.
Okay, this is. Anybody recognise this, guys?
I recognise it, but I couldn't tell you what it is.
Michael, do you recognise that?
Not really. No, sorry.
No, Roger.
It's a group of galaxies.
Well, it's
Yeah.
not Markarian's chain, is it?
No, it's the Perseus cluster.
Oh,
Oh.
right.
Now, what is this image? More specifically, what is the black area? And let me tell you what the black area is. This is extremely diffuse light spread throughout the cluster. And in fact, this light is so dim, it's about 100,000 times fainter than our darkest night sky here. It's extremely diffuse. And scientists have been trying to work out where it's come from, and they made an amazing discovery. The light is coming from stars that have been kicked out of their galaxies by galaxy collisions within the cluster. And this light permeates the whole Virgo cluster. And they have discovered the stars that are giving rise to this extremely faint, diffuse light. Do you know how many stars they've counted have been kicked out of galaxies in this cluster?
Must be billions.
1.5 trillion.
Trillion. Oh, okay, then I was a
Trillion.
little bit out.
Yeah. There are actually 1.5 trillion stars that, through gravitational interactions with galaxy collisions in the Perseus cluster, have been kicked out of their galaxies and are roaming between the galaxies. And this is a big discovery because this diffuse light has been known about for a long time, but they finally nailed it down to 1.5 trillion, what are sometimes called rogue stars, roaming the cold, dark intergalactic space. So this was quite an amazing discovery. I just thought I'd show you that. Now, moving on, discovery on Europa, made, believe it or not, by Juno when it did its flyby, and this thing in the yellow box here, it's being nicknamed the platypus because apparently to somebody it resembled a platypus. I don't see it myself, but never mind. That's not the important thing. What is it? It's thought that this is deposits in salt water that has risen to the surface from Europa's underground ocean. Extremely excited. And if you look to the north, there's a blue box, and inside there you can see two ridges. And if you look to either side of each ridge, you will see stains that, again, are thought to be mineral deposits from seawater welling up through those cracks, those ridges on the surface of Europa. So this is more evidence that Europa definitely has an underground ocean, and we're seeing seawater being ejected out onto the surface, and then the minerals are sort of freezing out, giving us these weird features. So that's a big thing this week, and there we are. So if this proves to be what it is, as I said, it's more of a demonstration that there definitely is an underground ocean in Europa. More than that, that underground ocean is thought to contain more water than all of Earth's oceans put together. So this is why there are two probes going to Europa to look at it up close and try and figure out what on Earth is, or what on Europa is going on. So there you have it. Yeah. Interesting news about Phobos this week. Now, Phobos and Deimos are, as you know, the two moons of Mars. They're shown here in a composite image with Mars in the background. Now, Phobos is a bit strange. Does anybody know why Phobos is a bit strange?
Well, one's well, I was just going to say one is actually moving away from Mars, and one's actually being drawn in by gravity. I know
Right,
that.
right.
Go on then.
Phobos is a bit strange for a couple of good reasons. So let's have a look. So this is the surface of Phobos. It's got these immense grooves running across it, the origin of which is still a bit of a mystery. But it turns out we may not be looking at what we think we're looking at. So it's always been thought that both Phobos and Deimos were asteroids captured from the asteroid belt by Mars gravity. But it turns out that they, at one time, formed one object. They were joined together. And that object was not an asteroid, it was a comet. And there's now a hypothesis that both Phobos and Deimos are chunks of a comet. And why do scientists think this? Well, the strange thing about Phobos is that its reflectivity, its albedo, is not uniform over its surface. That is not typical of an asteroid. It more resembles a comet. Also, the surface appears porous in places, much like a comet's surface does. And its photometric properties, the way it reflects light, is similar to the Jupiter family of comets. For example, the famous 67P that was visited by Rosetta, you may remember. So the hypothesis is that Phobos and Deimos were once one object, and we're actually looking at the core of the nucleus of a comet and not an asteroid. And its color is due to the accumulation of dust on its surface. That dust may have come from Mars itself. You know, Mars has these immense dust storms. But we may, underneath that dusty surface, we may be looking at ice, and it may be a comet. So that's quite interesting, I thought. Now, we've been talking about the sun a lot recently, but there's another interesting thing about the sun. Now, here is the sun on the 20th of May, and its magnetic field has been overlaid on top of it. Now, on the sun, different latitudes of the sun rotate at different rates. It's not a uniform rotation. Now, these different speeds, these different oscillations, as they're called, are very interesting. They're called torsional oscillations, and they're actually correlated with the sunspot cycle. So the rotation rate of those latitudes actually varies with the sunspot cycle. Now, that in itself is a bit weird. It's always been thought that the sun's magnetic dynamo, if you like, is buried deep within the sun itself. But that cannot explain these torsional oscillations. For these to happen, the actual magnetic field of the sun must be generated at a very, very shallow depth, probably not that far beneath the surface of the sun. Now, you know, if you think about this, it's quite natural to assume that the magnetic field is generated deep within the sun, maybe a couple of 100,000 kilometers. But the way that these torsional oscillations behave means that that cannot be the case, because sunspots, as we know, are governed by the magnetic field. The sun has a magnetic cycle as much as it has a sunspot cycle. They're all related. They're all part of the same phenomena. And the hypothesis is that the magnetic cycle and these torsional oscillations are just different manifestations of the same physical process, and the actual magnetic field of the sun is generated not that far below the surface, which goes against what we've always thought. So that's a fairly nice discovery. I have to say this is just a hypothesis at the moment. It needs future observations to put it on its way to becoming a theory. But it is a nice hypothesis and does explain things that the old idea of a deeply buried magnetic dynamo just doesn't explain. And then lastly, guess what? Einstein's been proved right again, and this time we're on the subject of black holes. Now, as you know, a lot of black holes have an accretion disk of very, very hot plasma orbiting them. there's a region towards the black hole where anything that goes into it immediately gets sucked into the black hole by its immense gravity. Now, what Einstein said was there must be an area there where the plasma behaves very much like a waterfall, with this waterfall representing the plasma that is being suddenly pulled into the black hole, much like a waterfall behaves. And this is known as the plunge zone, and it was predicted by Einstein. Now, using radio observations, a team of scientists from Oxford have actually discovered this plunge zone, thus demonstrating again that Einstein was absolutely correct and that the plunge zone does exist. What they also say is that at the plunge zone, gravity is probably at its most extreme anywhere other than a black hole, really, really extreme gravity, as this material just gets a bit too close and in less than a blinking of an eye gets pulled into the black hole. And there you are, and that's the plunge zone. So Einstein has been proved right again, the discovery of the plunge zone near a black hole. So there we are. So that's the news for this week. Some really interesting things. I think you'll agree.
Yeah, because you were talking about the very early galaxies. What were you saying? 300 million years? Was that you were saying? Yeah,
give or take.
Yeah. So was a few million amongst friends.
Yeah.
But of course, we've also got the theory is that the stars that were produced at that time as well were also very massive, because the amount of fuel that was available to them was astronomical. Because so yeah, it's all very, very, very interesting. It and the further we go back, but like you say, is how big these things are as well. It's sort of turning things on their head. We really got to try and get our heads around the beginning of the actual universe. And it made me, because of course a lot of people saying, well, is this pointing to it's being older than what we originally thought?
That's nonsense.
Yeah, well, yeah, but the thing is, we've got to come up and we've got to be able to say why it's nonsense. And of course, absolutely. At the moment, we really can't, because we weren't expecting to find these massive galaxies, and of course, some of them are well formed as well as spirals, which we didn't think come along until.
Well, the spiral galaxies appear around the 1 billion year mark. Again, that's a lot earlier than we used to think. But how do we get from those sort of amorphous blobs of the objects I showed you today to those majestic spirals? What is the evolutionary path exactly? We don't know. We really don't know. How can you take something that looks like those new early galaxies that have been discovered and end up with the majestic spiral galaxies that we know and love? What's the path? How does it happen? And more to the point, how did those galaxies form in the first place? It's the leading theory is that they formed around seeds in after the Big Bang, the areas that were slightly a few millionths of a degree cooler than the surroundings, and these acted as seeds for the birth of galaxies. Particularly, we think that they formed around dark matter, but there's so much to discover. Now, don't forget that the Webb, if all goes well, the Webb will last, will have a complete lifetime of 20 years. We're only a couple of years in, so who knows what the remaining 17, 18 years are going to going to unearth. It's so exciting, and we will report all of it here on Space Oddities. I don't know about the next 20 years, but we'll certainly give it a go. So,
Bob LeBlanc has just put in the chat. He says, "Hi all. Heard recently, shape of first galaxies is a rolled crepe. I suppose it means the actual pancake thing, shape. A new shape category of galaxies due to dark matter effect. Oh, that could be.
Oh, that's interesting, Bob. Thank you for that. I hadn't heard that.
Yeah.
That's interesting. Um, we know that the evolution of galaxies, we think, is inextricably linked with dark matter. That basically the galaxies did form around concentrations of dark matter, but we don't know we don't know exactly how it happened. So rolled crepe, I like that. Yeah, that early galaxy did look a bit like a rolled crepe. You're right.
Yeah.
So there you are. Okay, thank you very much for that, Bob. Anybody else got any comments? Please do put them in the chat. And any questions you have any time, just put them in the chat, and we will do our very best to answer them. Okay, so Michael, I see that you haven't got your presentation ready.
I've got it on my screen. I'm going to
okay.
from my screen, just share my screen.
Okay, fantastic.
Yeah.
So,
So, are you ready for me?
Oh, I'm always ready for you, Michael, as you know. So yes, when I see it appear, we'll move on.
Okay.
So Britain has a new spaceport, which you may be aware of, Saxavord on Shetland. Why so far north? Well, basically because it's a great place to launch into polar orbits, which are proving to be increasingly popular among spacefaring nations. Because, well, I'll let Michael explain all that. But so there we are. And Michael is going to tell us all about what's going on at Saxavord. And there you are. So take it away, Michael.
Okay, thanks, Andy. It's great to be here again tonight. So tonight I'm going to give you an update on the two spaceports that we've got. One operational and one almost operational. Spaceport Cornwall, as you all know, had their first flight in January 2023. I'll talk about that in a minute. But also, I'm going to talk about Saxavord Spaceport on the north tip of Shetland Islands. So, the United Kingdom has been involved with spaceflight for decades, building satellites and robotic spacecraft, rocket launch development, communications, and astronauts. These endeavours have taken place in collaboration with other countries and organisations. Now, the UK is aiming for new heights with the prospect of space launches from the UK soil. The UK government, along with the UK Space Agency and the Civil Aviation Authority, published new parliamentary regulations in 2021 to enable rockets carrying satellites to launch from UK soil for the first time, with spaceports planned for Cornwall, Wales and Scotland. This is a map of the UK showing the proposed spaceports. So you've got ground launch directly from Spaceport in blue. So you've got Shetland and Sutherland in the north of Scotland, and the Western Isles on the Hebrides. The air launch, those in blue are actual rockets launching from the ground. Air launch from carrier aircraft we have in Argyll, Prestwick, Snowdonia, and as you all know, Cornwall. I'll talk about that in a minute. Okay. So Spaceport Cornwall partnered with Virgin Orbit to utilise their Cosmic Girl carrier aircraft and their launch of one satellite launch rocket to place satellites into low Earth orbit. This is a photo or impression of what that would look like in the air just after releasing the rocket from the underside of the wing. So this is Cornwall Airport itself. It's a 9,000-foot runway, one of the largest in the country, and Cornwall. This is a map showing the location in relation to Land's End, so you can see where it is. So it's a really long runway and can handle 747 aircrafts. So it's quite good, useful for that. Spaceport Cornwall was officially launched in September 2022 with the opening of their Space Systems Integration Facility, or SSIF. The Spaceport is home to the Centre for Space Technologies, consisting of the SSIF and the Space Systems Operations Facility, and adjacent R&D work and office space. So this is a nice picture of the 747 Cosmic Girl with the launch of one rocket underneath the left wing being prepared for flight. Okay, and it's a nice image of the actual aircraft itself. The first launch from Spaceport Cornwall it took place in January 2023, but after being released by Cosmic Girl, the launch of one rocket suffered an upper stage engine anomaly at approximately 112 miles altitude on its ascent to space, failing to retrieve orbit and resulting in the loss of the payload. The flight was the only mission carried out from the spaceport using Virgin Orbit system. And it's another shot of the system there being released. Cosmic Girl and Launcher 1 made 6 flights from 2020 to 2023, resulting in 4 successes and 2 failures. The actual failures were the first failure was the first flight, which was a test flight, and of course the Spaceport Cornwall flight. After the flight from Spaceport Cornwall failed to reach orbit, and with Virgin Orbit facing financial difficulties, the company laid off staff and suspended operations in March 2023. The company filed for Chapter 11 bankruptcy, and an auction took place on the 22nd of May 2023. Cosmic Girl, the 747, was actually sold to Strato Launch, the hypersonics firm, as a carrier for their Talon hypersonic atmospheric plane. Virgin Orbit's Long Beach, California HQ was sold to Rocket Lab USA. Launcher, owned by Vast Space, successfully bid for the Mojave-based facilities, but there were a number of Launcher 1 rockets in various phases of production that were actually scrapped. Spaceport Cornwall has been in talks with other companies, namely Sierra Space, for their Dream Chaser spacecraft as a possible landing zone after launch from the United States, and also Space Engine Systems as a landing site as well. But a bit of breaking news, I think. Spaceport Cornwall is also in talks with a German company, Polaris Spaceplanes. They are building, and they're a German startup company, which are building their Aurora spaceplane, which will fly from Spaceport Cornwall as a single-stage to orbit vehicle. And this is a diagram of the actual finished article itself. And this is a test flight aircraft that took place. Test flights took place in August 2023 successfully. And this is just another shot of the Aurora spaceplane in orbit. So that's looking quite good for Spaceport Cornwall. So although Virgin Orbit was closed down, Spaceport Cornwall is still working towards future flights. Okay.
That's a pretty sexy beast, though.
Oh, it is. Yeah.
The Delta wing.
Yeah.
I believe it's an uncrewed vehicle. as it is. Whether any crewed versions will become available, don't know.
I still think, Michael, that Skylon is the last word in sex.
Yeah. Unfortunately, that we haven't heard a lot from that for a long time.
No.
So, okay. Next up, I'm going to talk about Saxavord and RFA, Rocket Factory Augsburg, who are going to launch from there later this year. Saxavord is probably the most northern point of the United Kingdom. If you look at the map on this slide, you will see you've got Shetland above the north of Scotland, and Saxavord Spaceport is right there, at the top of the Shetlands, and there's a blown up image there. It's actually on a peninsula called Lamberness in Unst, Shetland. And it's near the old RAF Saxavord radar station and the settlement of Secor, adjacent to the Saxavord distillery. Might be interesting. Other than the North Sea, there is nothing to restrict flight trajectories to sun-synchronous, polar, and high inclination orbits, or for suborbital sounding rockets. So quite a range of possibilities there for launches from Saxavord. And this is a map showing the actual site itself. There's proposed to be 3 launch pads. The launch pad that's currently built is launch pad Elizabeth on the extreme edge of the site. That launch pad Elizabeth was named after our late Queen. Launch pad Callum will be the next site, and launch pad Freddo. So on the next site.
It's got some big seals there, haven't they?
They have, haven't they?
Massive,
Whales.
Yeah.
Okay. And this is a shot of the launch pad Elizabeth as it was a few months ago.
Looks very different now, actually.
Yeah. Okay, so a little bit about Rocket Factory Augsburg then. This is their RFA-1 launcher. RFA offers precise, flexible, and low-cost launch services. Real-time data from satellites Real-time data from satellites will soon form the backbone of our research, industry, and society. Our goal is to democratize access to space in order to better understand, protect, and connect our planet. That's their blurb. This is RFA-1. You have 9 engines, 3 stages, 1 flexible launch system. RFA develops their Helix engine in-house and used low-cost stainless steel with other industrial components from the automotive, oil, and energy industries to construct the launcher. The cherry on top of the launcher is RFA's unique orbital transfer vehicle called Redshift. And this is Redshift itself, to carry satellites in various configurations, multiple satellites or 1 or 2 satellites to their desired orbit location.
Any idea how tall that rocket is, Michael?
No, I haven't got the information in front of me.
Okay,
to find out. So basically, they say that we position your payload exactly where you want it to be. Our last mile delivery service takes care of any mission profile, from low Earth orbit to geostationary transfer orbit and beyond. Our Redshift's orbital transfer vehicle helps you achieve your business and scientific ambitions. Rather
yeah. By the way, I've just checked. RFA-1 is 30 meters tall.
Right, okay. So just a list of in-orbit services here. You have hosted payload, space debris removal, life extension, satellite inspection, and end-of-life management. So this is showing the different types of payload. So you've got dedicated payload for larger satellites, one company maybe, and you've got the ride share, which carries multiple satellites. And last month, the they did a hot fire test of all 9 engines on the first stage, and it was a complete success. So that was a good milestone for them to achieve last month.
Quite an impressive video of that, there was.
Yeah, there is, yeah.
Yeah.
And they do intend to do more hot fire tests in the coming months with a view to a first launch later this year. And that's RFA 1.
Fantastic.
So,
Nice.
Great. Wonderful. Thank you ever so much, Michael.
Okay.
That's really good.
Oh,
So,
thank you.
so the UK ploughs ahead with getting into space. As you may know, the UK space economy is now worth, I was reading the other day, between 18 and 19 billion a year to the British economy, which is fantastic. And all seems to be going to plan.
Yeah.
On the other side of the Atlantic, this week things have not gone quite to plan. We had the live coverage of the Boeing Starliner launch, or at least we were trying to cover it live. And unfortunately, yet again, the launch was cancelled, this time at 3 minutes and 50 seconds before liftoff, because of a groundside computer problem. So the launch didn't happen. It's now scheduled for tomorrow. At what time is it, Daz?
What I say, 3:25?
3:25 UK time.
Yeah.
So I hope that we'll be covering that live. If Daz and Roger are both available, they will be covering the launch live on Space Oddities. And let's hope finally that the Boeing Starliner can launch. Even if it does launch, this complete Starliner program has been such a disaster for Boeing that it's now running 7 years behind schedule, and it has been completely outclassed by the other vehicle that was contracted in 2015 for the commercial crew program, that being SpaceX, of course, with their Dragon spacecraft that has now made lots of flights, both carrying cargo and carrying crew to the International Space Station and back, and the whole mission has, or the whole project of the Dragon has been a resounding success. Boeing were contracted at the same time as SpaceX, but 7 years later, still trying to get that thing into service.
Yeah, but with half the money.
Yes, that's right. SpaceX did it with half the money that was awarded to Boeing. The whole Starliner spacecraft has been a catalogue of errors and disasters, many of them avoidable, due to let's not beat about the bush, due to incompetence on the part of Boeing, and it's just a sad story. However, in March, NASA did award the Starliner 6 extra flights on top of what it had been contracted for, which seems excessively optimistic, bearing in mind the problems. Admittedly, the last couple of this launch that was cancelled at the weekend was actually not the fault of Boeing. That was, as I said, a computer problem groundside. But if ever there was a spacecraft which seems jinxed, then it's certainly the Boeing Starliner. On the other hand, Thursday sees the integrated flight test 4 of SpaceX's Starship. Now, this is the 4th attempt to get Starship working and getting into service. This time, the emphasis will be on recovering the booster and the Starship, bringing them both back through re-entry safely back to the Earth. And this is really the last bit in the chain that needs to be fixed, because, as we know, in the previous flight test, both the booster and the Starship were lost. But SpaceX thinks they found the problem, or they found what the problems were, and they've designed solutions which should work, hopefully, this time. If the integrated flight test on Thursday is a success, then there will be a lot of released breath, shall we say, at SpaceX and NASA, because, as we know, SpaceX is contracted to build the lunar version of Starship to put people back on the moon. Take a guess when it'll be, because at the moment they're saying 2026, and it's almost certainly not going to be 2026. It's going to be later. However, SpaceX do have the contract to build that lunar lander, which is, as I said, a lunar version of the Starship. So we will see what happens on Thursday. We will, of course, endeavour to cover that live as well. Unfortunately, we don't know at the moment what time the integrated flight test is going to happen. If it follows previous flight tests, it will launch sort of, I think the last one was about 1 o'clock in the afternoon UK time. But we don't have any word yet as to what time of day the launch is happening. Do keep an eye on the channel. As soon as we know, we'll get something organised in terms of coverage, hopefully, and there we are. We're all looking forward to that.
Yeah, of course, because not only is the going back to the Starliner, it's important to get this off the ground. They are flying it with issues, but they've waived them. They think they can mitigate any problems with them. The leak that they found in the actual capsule itself is lessened. They said it's actually decreased in the meantime. So hopefully that's a good thing. And it's I predict something will happen tomorrow to Starliner.
To be honest, Ian, I'm with you. To be honest, I'm not at all confident that it will be a successful launch.
But also, it's a big day for ULA, the people who are providing the actual launch from the Atlas V and the Centaur units. Of course, it was a Centaur that had the leak, or they say it's not a leak, but if you've got gas passing a valve, that's a leak. If it's internal or external, you've got a leak. But they replaced that. But what happened this time, as Andy said, it's all ground side, and this was to do with the computers, and it's all a bit conflated. But basically, you got three computers. One does all the work, the main work. But at the end, when they get to the sharp end, when they get to the terminal countdown at the very end, all three computers come on and they check everything that is safe to launch with that vehicle, and everything must be spot on. And what happened is, and they check all these things at exactly the same time, and confirmation of go or no go must happen instantaneously. But one of the computers had a bit of a lag on it. And when I'm talking about a lag, you're probably talking about a fraction, the smallest fraction of a second. And that basically brought everything to a halt. Because if there's a problem, if there's a delay, it sees it as an error, and that actually stopped it. But of course, they couldn't go and check the systems until they fueled it, and everything was safe. And it's probably just as simple as you got a big bank of. It's like the computers you see on, Mission Impossible or something like that. There's a big bank of them. There's three of them, and it looks like they're all got little shelves, and they plug in different cards which actually deal with one or two items on the list that has to be gone through. And if it's just one of those is slightly failing or anything, they can just take it out, plug a new one in, and that should resolve it. Or there could be a problem. It's just, but for ULA, this is also a big moment because they've had a pretty good record up until this sort of event.
In terms of reliability, they have.
Yeah, especially with the Atlas V. And so it's very strange for all of this to start happening. But of course, I did hear someone talking, because when the Atlas V have all gone, because they've only got about 5 or 6 left, and any more are all designated to other missions, so there aren't any more to think. But once they're all gone, they're gone. So what are they going to fly this on next? Because I think they're going for. Was it actually going to be the New Glenn? Was it something like that, the New Glenn, or is it going to be the Vulcan they were talking about again? Which is,
good question, yeah, because I was thinking that.
Because they've got problems with the Vulcan. They've got problems with because that's not certified. The New Glenn, still haven't seen one. So once all the Atlas V's gone, if they do manage to achieve a result and get this certified this time, once those have all gone, what are they going to launch the Starliner on?
Yeah, very
It's
true.
they've got to come up with some. This
And
has all been very badly mismanaged and things like that. Because I mean, ever since they dropped the shuttle, which for obvious reasons had to go, and then they basically left themselves with no launch vehicle into space, so they had to turn to the Russians, and of course that's all turned foul. Then they said that ULA can't use Russian engines, so which they use for the Atlas V and all their other fleet. So they're basically being running down their stock, and once they're gone, they're gone.
Alan makes a good point as well, Daz, that Dragon can't be used to raise the orbit of the ISS, whereas the Starliner can.
Yeah, exactly. Yeah,
So, absolutely, Alan. It's important for that reason that this happens. But, I don't know. I think, if this goes on much longer, if the Starliner fails to launch again, and it's something, this time to do with the Starliner problem with the Starliner, NASA, I'm sure, are coming very, very close to cancelling the whole thing.
Yeah.
But, they will need a spacecraft to raise the orbit of the ISS from time to time. And I know SpaceX are looking into redesigning the Dragon so that it will be able to raise the orbit of the ISS. But it's all a bit of a mess, to be quite honest. So there we are.
But it's also needed for redundancy, isn't it?
Well, exactly. But of course, with the Vulcan, this is already in dire straits. The ULA Vulcan, because excuse me. I mean, the whole idea of ULA was to give the US military instant access to space. They would be launching virtually everything that the military wanted put into space. It was basically a government quango. It was a monopoly. But of course, without the Vulcan, they've had lots of orders from the military, and of course they're not being launched. And apparently they're stacking up. They got about five or six satellites that are backlogged up, and of course they've now actually been fined by the US military for these delays, and it's making them more and more vulnerable to because I know they've been up for sale. I don't know where that actually stands, but the last I heard is that the only person interested was Jeff Bezos. I suppose it's because it's the only way you can get into space. He hasn't achieved it yet so far. And what's this about teapots and mugs?
Well, the conversation started in the chat. Basically, our viewers are demanding, not requesting, they are demanding
a mug.
Mugs.
You got 4 on the screen now.
Yeah, absolutely. True. They want younger ones now. They want newer mugs. So yes, I mean, it's something we can certainly look at. We'll turn this over to our merchandise master, Mr. Michael Bryce.
Hello. I'm on it, guys.
Yeah, we'll see whether we can get some mugs done for you. But Lee suggested a fine bone china teacup, saucer, and a novelty teapot, a marching teapot, which would be great.
So would that be a Changi mug?
Yeah, probably, but we will pass that over to Michael and see whether we can get some mugs sorted out for you. If you would be interested in buying a Space Oddities mug, can you indicate now in the chat so that we have an idea if this is a goer or not?
Yeah. I mean, Sandra says hopefully not is a Jeff Bezos shaped mug. The only rocket they have got. This
was something else. The last mission of the what's it called? The blue something, Blue Lagoon. I don't know.
What? No, you mean the new Glen?
No, not the new Glen. The flying phallus.
Oh, you mean the new Shepherd?
New
New
Shepard.
Shepard,
Thank
yeah,
you.
New
Thank you.
Shepard.
I had a
Yeah, the
great
blue stuff's on the moon, isn't it?
158.
That's the moon stuff.
Yeah, this was something very odd. That, as you may have seen, the New Shepard, when it returned from its last mission, taking people to the edge of space, although they did go above the car line, so technically they were astronauts. Yes, we know all that.
Yeah,
But anyway, it's tourists.
technically, but
Technically, it did include an African gentleman who was picked as one of NASA's first astronauts, but
Yes.
never got to fly.
Yep.
And now he's 90 years old, and he's finally made it into space. And that was fantastic. That was worth doing. Anyway, on its way back, one of its 3 parachutes failed to open properly.
Oops.
And they know why. There's this thing called the reef line, which helps the parachute inflate, and it didn't sever itself from the parachute after it had done that. There's a cutter that's meant to cut through it and cut it free, and that didn't work.
Mm.
But nonetheless, one of the 3 parachutes didn't work, and Blue Origin said it's no big deal. It can land on one parachute if need be. However, Blue Origin said that they hadn't made news of that public, which was really bizarre, seeing as everybody saw it live on TV. And so when we saw it, oh look, the parachute hasn't opened. That was really bizarre.
Yeah.
I don't know what's going on there. Anyway.
Well, the thing is, they said. Oh, sorry. If you.
So Lee says, yes to the mug, please, and the Space Oddities teas made too.
We've got nearly. Well, I think we got nearly 10.
And
nearly 10.
Yes, and Sandra says, Astro Matt, hi, Astro. Yes, he's interested times 2. So
Ian's being awkward.
Stuart says, yes, please.
Who uses a tease made now?
Yes. I mean, I think that's definitely. Sandra says an open nose came for the spout if we had a teapot. Yeah. Okay. Well, I take it that's a yes. So thank you, viewers, for that. We will. Michael will get on the case and research that and look into the
Ian's being awkward.
See what we can do about that.
He wants a
so thank you so much, and we do appreciate your enthusiasm for Space Oddities mugs.
Yeah.
So,
going back to the Blue Origins and the flying phallus, as you say, because apparently that, like you say, there's that cable that actually holds it shut, but it's supposed to be spliced. Now, when does that happen?
I'm not sure exactly.
Because it seems very strange because they say it's to stop it opening fully, and then it's supposed to be cut. But what's doing the cutting, or is it sort of like a serrated thing and pressure supposed to rip it or something? I don't know. It seemed very strange, but like you said, NASA used the same system, so that's why they've
they said it had been used and tested, many times before without problems. So this is just a one-off, and I'm sure it's no biggie really. Yeah. But surprisingly, the FAA have not launched an investigation, which I was sure they would. But anyway, we will see. Let's move on. Daz, it's your turn.
Yeah. And, right. Okay then. Yeah. If you can just pop it up for me.
All about what's happening on the sun.
Right. First of all, I must apologise. All I've got is 4 slides. I've been struggling today. I don't know this for some reason. Something's changed. I couldn't get the videos to download into PowerPoint on my machine. I was able to get them on my older machine, but when I tried to transfer them over, it was saying the files are too big, which is a load of nonsense. So it's going to be more of an oral update and bit of a review. But basically, as Roger said, we've had 2 of our old friends come back onto the Earth-facing side of the sun this week, and unfortunately A3663, which is I'm sure it's its 4th time round. That was very, very disappointing, and that became AER 3691, I think it was. And that's been basically, it's just along for the ride, I think it is. But it was followed by another sunspot region, which I'm sure we'll see in a minute. What I'll do, I'll talk about it in those in a little while, because the first thing I want to do, and apparently I think it's this year, is the year of solar heliophysics year. So it's the year of the sun. And there's lots of events going on. But really, we do need to take this seriously. And there's a couple of things that I just want to bring out. Now, I don't know if you can remember going back to the 20th of June. Let me just sort myself out here, because I'm in. So going back to the 20th of June, I did show you a coronagraph image where there was a faint 360 halo. Now, usually 360 halos means if it happened on our side of the sun, we were going to get something.
Are we meant to be seeing? Sorry, if we meant to be seeing a different slide at this point, because
not at the moment.
Okay,
I can do. We'll move this on, because this is part of it.
Yeah.
And what it was is it was a 360, but it was confused, because at the same time that happened, we had a big liftoff of a big prominence on the actual sun. So when they were trying to analyze the prominence, it was all confused, and they couldn't. And when they went back and looked at it, they saw embedded in this whole thing was this 360 halo that it erupted off. So what they did is, luckily for us, the solar orbiter is on the far side of the sun. So they're using the STIX instrument on the solar orbiter, and STIX stands for, and I don't know how they get this, X-ray spectrometer telescope. So it's not even in the right order. They using that, they were able to measure the light curve of the explosion on the far side of the sun. And again, it was our old friend AR3664. Before it had come round on our side. As I said, this was the 20th of June, and it was measured. This is the actual light curve here as it was measured, and that equates to an X12 flare.
Wow.
So yeah, that was a big one. And luckily it was going away from us. If it had happened to us on the Earth side, no matter where it was on the placed on the sun, we would have got a big chunk of that. But that happened on the 30th of June. Then, of course, later on, it started moving around towards the eastern limb to come round. And again, it fired off another big flare, which again was seen by the solar orbiter. And when they checked this one, it was an X1 flare. So that would have been facing towards us. But they were also saying that, and then, of course, as it moved around again, there was another large eruption from the same sunspot. And it was measured by GOES, which is a geostationary orbital environmental satellite. That was measured as an X.28. But again, using the solar orbiter data and the STIX again, they measured it as a X3.7. But because of its positioning, it would again be the same as us. It was right on the limb, so it didn't actually get to see the very base of it. So that could have even been more. So that gave us a bit of anticipation for where it actually, for it actually coming around onto our side of the sun. Now, also, the other thing I would just like to say, and this is going back to May the 10th, and this is why I said we really need to take these things a little bit seriously and to look at it. I mean, we all know that we've survived very big solar flares. In the past, we've had all the Carrington events, and we've survived several of them, some of them quite recently. But of course, as we get more and more dependent on electronics, we're getting more and more in the position where we could have a big incident. And just to enforce this, if you remember on May the 10th, we had the geomagnetic storm, which gave us all the lovely aurora all over the UK. And what happened there is SpaceX reported that although their satellites all coped well, they survived. Um, what they did find is they suffered extensive downlink disturbances. So, and
Right.
when we talk about that, is that basically the actual performance of the Starlinks failed a lot.
Mm.
And the reason they knew that something had happened is because everybody complained, and all of a sudden whereas their complaint line was going along quite steadily, all of a sudden it shot right up. So they were able to see that for that period of that storm, which of course lasted quite a few hours, they had quite a bit of problems with the downlink actually reaching uh, the the units on Earth. And of course, it also almost when you looked at the line for the complaints, it also followed as each of the because again it was a stack of different geomagnetic storms all piled up together. As they individually hit, you could see the complaints going up and down. But then finally it all settled down. So yes, it was good to hear that the Axel satellites survived. They did have the because as we're learning, the more warning we can give to um, power stations, power networks, power companies, and everyone else, they can switch all these things off that they can. And as long as it's not a sustained attack, well, let's say attack, a storm a group of storms that lasts over 4 or 5 days, we can survive them without any notice to us at all, except we'll probably have lovely auroras everywhere. So I'd just like to say that this is why we've got to sort of like look at these things and make sure we know what's happening, make sure we've got the assets to be able to study both the near side and the far side of the sun. And because with the more warning we can give ourselves, the better. Anyway, back to I just thought you'd like to know that. That's just all a bit of recent historical stuff. Right, so here we are. This is from the 28th of May to the 4th of June. As you can see, on the 24th of May, we had 8 active regions with 116 sunspots. We're at the present. We've got 11 active regions, but the sunspot number is 208. So there's quite a lot of sunspots on the Earth facing side of the sun. And the geoflux, which is of course with sort of like the solar wind part of it, is 186 at the moment. Now, we started the week quite calmly. A A3663 and A3664 were already on our side of the sun, but not a lot happened to begin with. We had quite a few flares on the Wednesday. There was 21 flares altogether. Over the week, we had approximately 112 flares. But there was nothing really to shout about. They were all low class C and M flares. But we could see that there was a far more activity happening in the coronagraphs on the far side of the sun, and of course, solar orbiter was recording these things. Then on the Thursday, AR 3664, which has now been named 3697, started to get its act together, and it kicked off our first X class flare, which we haven't had for a while. And it was an X 1.4. But it was mostly Earth away. Most of the ejection went away from Earth and all that, so we didn't get much of that actually coming towards Earth. Then, so what was that? Right. So yeah, that was Wednesday. And the only thing is, on that day we only had 12 flares, but as we said, one of them was the big flare. Now there was a prediction that there was going to be an auroral display that night, but I don't think it came to anything. I didn't see anything really. If it was probably up around the Arctic Circle. On the Thursday, it was just another quiet day. Not a lot happened. But we had 13 flares, and all of them were C class, so they were really low class flares. Then on the June the 1st, we had an X 1.1 flare from our old friend 3697 as it is now. So he was starting to get his little bit of his act together. Again, it was away from us, so we didn't really get much in the way of action from that. Sorry, I think I've lost my page. In fact, actually, sorry, there was two. There was an X 1.1 and an X 1.4 flare on that day. And then later on that day, it actually kicked off another flare, which was an X1 flare. But of course, that came into the next things. So that day we had 19 flares. But then on the 2nd, this is when it really got itself going just for a while. A3697, our old friend, it fired off an X1.0 flare, but within 30 minutes it fired off an M4.4 flare, followed closely by an M7.4 flare. So that was all within half an hour. Now, there was all these X flares that have gone previously, even this X flare, there was no coronal mass ejections really associated with them. But when the M7.4 flare went off, half an hour after the X flare, again, all from 3697, there was a coronal mass ejection, which gave us a 360 aurora, an asymmetrical halo. Sorry. An astrometric, gave us a 360 halo. So we knew something was coming our way. Now this is due to hit tonight. I have seen some press building this up that we're going to have big auroras like we did before. Personally, I don't think we will. Hopefully, if these have banked up against each other, they've all caught each other up, and there's some big pack. Because if the M7.4 flare did have a big ejection with it, that's going to be moving faster than the two in front of it, so it will push into them and push them in further. Now that may give this a bit of an oomph, but I don't think we're going to see. I mean, they're predicting that at best possibly we're going to get a G1 geomagnetic storm, which basically means it'll be confined to the Arctic Circle. But maybe, just maybe, if they have bolstered up, it's given it a boost, we might be able to see something a bit lower. But I don't expect what we saw before.
Okay.
So, it's just today. We've had not since then. It's all decreased, and everything's sort of like quieting down again. But we are expecting some more, but we could expect some more from our old friend before it disappears, and that'll be great. So keep an eye on the skies. Keep an ear out for your alerts, and we will see how we get on. Okay, then that's it.
Right. Okay. So thank you, and thank you, Claire, for your question, which I think Daz answered. Claire also says, "What's the proton count?" I don't know whether you know that, Daz.
I haven't got it with me in this precise moment. I can't. Okay. I haven't got I've just sort of like taken this from the general reports and things like that. What I can say is that we've got 208 sunspots on the sun at the moment, and that equals the same as all of last month. That was exactly the same pinnacle as they had then, but it dropped down to sort of like the mid, sort of like the 140s, 130s, 50s for a long time. But yeah,
Right.
it's things that can pick up at any time.
Okay. All right then. So let's move on. Well, I think that just about brings us to the end. Thank you to Daz for that. Thank you, Michael, for that excellent portrayal of.
Yeah, sorry, no vids.
Yeah. No.
Yeah.
Excuse me. Thank you, Michael, for telling us about Saxavord and Cornwall. Very interesting. We'll keep covering, obviously, the British space industry. We'll let you know what's happening and when. Now, don't forget, we are, I think, are we not? Daz and Roger, going to be here tomorrow for
Yeah, I'll
yeah,
definitely log
hopefully.
on. And,
okay, so tomorrow at 3:25 UK time, the launch is programmed for. So I guess we'll go live at what, 3?
Yeah.
Okay.
Yeah,
So
we'll
3
go live.
p.m. UK tomorrow, our live coverage of the next attempt to get Starliner into orbit, and we will cover it for you. Apologies to those of you who are watching our coverage a few days ago, but obviously circumstances beyond our control that it didn't happen. Try again tomorrow, 3:25 UK on Space Oddities. Also, keep your eye on the channel because we hope to bring you the ITF IFT4, the Starship flight on Thursday. And as I said, we don't know what time that's happening yet. As soon as we get some idea, we'll create the live stream on the channel. So keep your eye on the channel, and we hope you can join us for both those events. Hopefully the launch of Starliner tomorrow and the SpaceX Starship on Thursday. We will be back, of course, next week at the same time in the same place, and we'll have even more fun then if you can stand the excitement. In the meantime, Michael has got some homework. He's going to research Space Oddities mugs, and we will let you know in due course what we turn up on that and whether it's going to happen.
Yeah.
And Derek, thank you, Derek, for your kind comment. And lovely of you to join us, Derek. Take care of yourself.
Good night from me, and it's good night from him.
Absolutely. So from all of us.
Just before you go, Andy, talking about the proton count,
Mhm.
the proton density at 3:00 this afternoon was at 2.5, and that's particles per centimeters cubed.
Right.
But that has now dropped down to about 0.7.
Right.
So it's very low at the moment, but it
It's
did
very
peak.
low, so
Did
probably
peak
not
at 3:00. So
no.
so yeah.
Okay. All right then. So thank you, everybody. Thank you for your generosity this evening as well, for your contributions. Thank you to all of you for watching. We do appreciate it. We'll be back at the same time next week, as I said. But until then, have a fantastic week. Stay safe. Take care of each other. Be good. And if you can't be good, as I always say, be average.
Yeah.
So
Hopefully
from all
with
of
some
us-
videos.
So from Michael, from Roger, Daz and myself, unfortunately, Lou was in a bit of pain when he came back from the doctor, so he didn't join us this evening. But hopefully he'll be back with us next week. And there we are. So from all of us at Space Oddities, good evening. Bye-bye.